but you have a lot of rain. So you also get runoff, and you have rain coming down that river, which is why you have a lot of flooding up in there. In terms of mapping, evacuation plans would be necessary. What they generally tend to do here is to generalize these maps to identify certain routes, to identify certain zones. Emergency responders and people who live in these areas can probably, if you have boundaries like that rather than those based upon elevation, they can get a pretty good sense of what's going on. But in order to get a really good coastal flood map, you have to have good elevation data, and those good elevation data would come to us from LIDAR. The entire country is going to be pretty soon, I think, we're going to have a pretty good elevation map based upon LIDAR. It's going to be much more accurate than the Standard Geological Survey topographic maps we have, where we have contour lines, and the contour lines might have, in low-lying areas, a contour interval of 5 feet, or maybe 10 feet, or perhaps even 20 feet in areas with relatively steep slopes. What about Hurricane Sandy? Well, how many of you have ever seen, it was on PBS, it must have been maybe 10 years ago, something called the Hurricane of 38. You're on Long Island now. You might even have some relatives who lived on the island, back then. This is a big storm which came up the East Coast and devastated points on Long Island, points in Rhode Island. Would cause quite a bit of interior flooding in the southern New England area in general. This was a storm that was not really forecast. And there was one junior forecaster who looked at the data and had a good sense that something bad was going to happen, but he was not sufficiently senior and his thoughts were not taken into consideration. And basically people thought that it was just going to be a storm which is going to go out to sea. No big deal. It turned out to be a very big deal. Hurricane Sandy is a somewhat different situation because they pretty much saw it coming. One of the reasons why they saw it coming is that we have geostationary environmental observation satellites. Geostationary, GOES, GOES, nice acronym. GOES 13 produced this particular image. A geostationary satellite is a satellite that is in orbit at an altitude of about 22,300 feet or 20,400 feet. I forget exactly which, over the equator, over the same spot day in and day out. So it's very good for capturing images of cloud cover at a 15-minute interval. So you can track the formations of these large rotating storms. And they are large, and you can see them very, very clearly. And you can see there's one up there, and we can look at it maybe a little bit more closely there. And we're using meteorological models, another kind of modeling, basically another kind of finite difference model. We use a grid system. And meteorological models also work with different layers so that they can recognize vertical differentiation in the atmosphere. And they can be fairly accurate. As the storm gets closer to the coast, they can narrow down the amount of on the coastline that the storm might hit. But you want to get a good estimate maybe about 48 hours out, because there's some areas where a coastal evacuation, that's not the kind of thing that you're going to be able to accomplish effectively with just a couple of hours. You have to start, more or less about 2 days in advance or more. This is the storm they saw coming. This is from a TV meteorologist. Actually, that station is out in Oregon, and there are several firms that provide software. But if you look at this, you can see Long Island, you can see New York Harbor, the Jersey coast is here. What's interesting too is you see a kind of V in here. This would be one arm of that V, this would be the other arm of that V, and this creates kind of a channeling effect. A lot of the energy of this storm, in terms of pushing water, is going to be concentrated in that area. And another situation, this is to the right side of the storm track. And if you think of the fact that this is a large rotating storm, and you don't want to be on the right side of the storm track because the storm comes up, you're actually going to have water being pushed forward like this. Okay? You're going to have a greater forward force in the onshore direction when you're on the right side of the storm track. Here's another example of a model showing some extremely strong gusts of wind. So they knew this thing was coming. Geological survey. Here's a model for Long Island. And our collision, basically waves striking the shore. Inundation would refer to farther inland. Here's one for the Jersey coast, based upon probabilities. I think an interesting map is this before and after map from the Geological Survey. This is, I guess you pronounce that Mentaloking, anybody know? Down along the Jersey shoreline. Basically, the left-hand panel shows you, and this is based upon a LiDAR survey. Before the storm, after the storm, it cut an inlet in there. And then we have a difference map in there. And ESRI, the people who produce the most widely used GIS system, have on a website, Hurricane Sandy, what they call the aftermap. And what it is this is a dynamic application where you can basically grab this line and you can wipe it back and forth. And this is not hooked up to the internet. I didn't want to risk that. But I basically have a screen capture where you can look at this one. And here we have the situation where this was before the storm hit. And then I took a screenshot where I moved that line down a bit further. You can see that that inlet has formed over here, that the highway system is not doing well. And then we can move it farther in like that, and you can see what happens. So basically, there's a lot of coastal reconstruction that's going to have to be done if they want to do that. The state of New Jersey, in cooperation with the Corps of Engineers, has a program known as beach nourishment. And the storms come in and wash the beach away, and then they try to build it up again. Costs a lot of money. I want to shift to talking about sea level rise maps and the fourth coastline. Because the fourth coastline is interesting because it's concerned about something that's going to be much more long-term. I mean, storm surge is concerned with land use control and flood insurance over a relatively short time span. Sea level rise over a much larger time span. And it's politically controversial. And there are some interesting ethical issues here about propaganda, because propaganda or persuasive cartography means that you're trying to get people to take notice. Propaganda, probably it has negative connotations. You think of Nazi propaganda maps. Recently it came out because this was an organization within the Roman Catholic Church which was concerned with the Committee for the Propagation of Faith. The idea basically was to persuade people that they should become Roman Catholic. Cartographers like to think of these maps as being persuasive maps. And one finds some interesting maps here. There is a dependence upon accurate elevation data. The idea is to show areas that might be affected by sea level rise associated with climate change. And the impact would be fairly significant in, let's say, low-lying nations like Bangladesh, where a 1.5 meter rise in sea level, that's about 5 feet, is going to affect 17 million people and roughly 22,000 square kilometers. There's an application running, I think, on a Google platform, where they basically, however, had a little indicator there where you could actually, you can look up in the extreme upper left, where you could indicate the amount of sea level rise, and you could, experiment, simulate the impacts of, let's say, 5 meters of sea level rise. This is an environmental publication that shows you the possible effect of increased sea levels on a barrier island. The impact would not be that orderly because wave action would probably do even more than just inundation. Just to get a sense of what's been going on relatively recently, and this is a good example. The National Oceanic and Atmospheric Administration has navigation charts along the coast. There's a chart from 1990. This is off the Louisiana coast. And you can see lots of bios. You can see that there are places that are worth naming. This is 1990. Fast forward to 2014. This is the same area. Increasing inundation. Now, to go in and take a closer look at this, I'm going to look at just the upper right-hand quarter of that map. And I'll go back to the earlier map here. You'll see English Bay. Okay? So there was a feature that was sufficiently significant as to be worth naming. You'll see several other place names there. And then we go to the more recent map, and we don't see those features. And basically, NOAA decided that they're basically just going to retire those names. As far as they can tell, those places, those physical features are not coming back. So now you see it, now you don't. Sea level rise is not uniform. Some places we actually have the land rising because there were glaciers there, and because the glaciers were heavy and they were pressing things down, and there's an isostatic rebound. So there is a measurable rise of the land level. And there are also situations, you can think of continents like this, and if this area is rising up, this area oftentimes would be sort of tilting downward. You have other situations here, where perhaps maybe around the Gulf Coast, maybe if you're extracting oil, there would be subsidence associated with that as well. But there are significant areas of subsidence which are adding to global sea level rise. A geography faculty member, University of North Carolina, 1971, and the whole notion of rising seas and melting glaciers is not new, thought, hey, how much of the world is going to be affected? So he basically took some maps and drew major cities and areas inundated by 100-meter rise in sea level. Now, is that far-fetched? Well, if you melt all of the existing ice, including the east and west Antarctic ice shelves and Greenland, you could get maybe a 100-meter rise. But that might well happen. And it might well happen before we think. But in any event, what Dick Kopec did was to sort of look at the fact that, basically Florida is not going to be a very attractive vacation land for senior citizens. Right now it's known as God's waiting room, but it's sort of like God's bathtub. He had a map looking at this on a worldwide level, and you can see it sort of gives new meaning to the term Great Australian Bight. You can see that Bangladesh and people at places, low-lying areas both to the east and west of the Indian subcontinent would be very badly affected. The most serious, I think, early article was by Stephen Schneider and Bob Chen with NCAR, and basically concerned with the link between carbon dioxide warming and coastal flooding. And they had a more plausible estimate of maybe 15 feet or 25 feet they had this map. This is not the original map. I took their lines and I put it on a cleaner version of a topographic map. But basically, they said it should be possible to row a boat from the White House to the steps of the U.S. Capitol. Not that it would do much good at present. Geological Survey has produced a number of maps showing differences in vulnerability. The U.S. EPA has a series of maps for different stretches of coast where they're showing you areas that are below 1.5 meters and that are roughly 1.5 to 3.5 meters above the water line. And you can see that southern Mississippi, especially the Delta area, is very much in danger. The EPA has been reluctant to put anything on these maps saying anything about sea level rise. The implication, I think, is obvious, but it just seems to be too politically sensitive to do so. But basically, you can, however, have, there's a map for Long Island. You know, if you're far enough inland, it's not going to hit you right away. But you can see that there are certain areas where there are very nice resorts that are going to probably be adversely affected. LIDAR can be useful. There's an example of a first surface LIDAR map. The first surface LIDAR being where the light would be reflected back from the surfaces of structures and trees. Algorithms could then be used to generate a bare earth LIDAR map, which is what the Geological Survey would like to use for its topographic mapping. Business as usual. Well, basically business as usual. Jim Titus is a lawyer, works at the EPA, and has very interesting ideas. They've tried to, being a Bush White House, have tried to censor him a few times. One of the things that he did was to talk with local planners and try to get a sense of what's likely to happen. And basically, there are some sections where the shoreline is going to be defended almost at all costs, which is to say they're going to put out jetties and groins, they're going to maybe build seawalls, they're going to use beach nourishment, and there are other areas where the shoreline is going to be allowed to migrate inland naturally. And I want to call your attention. Stand up on this. This area right up there. And that green area is Assateague National Seashore. And the brown area is around Ocean City, Maryland, where there are resort hotels and condos and all kinds of infrastructure. We can look at this map and see at present that there is a kind of an offset. There's an inlet there that was formed by a severe storm back about 1928. And at one time, if you go back in time, that island was one continuous island. So before the storm, after the storm. Before, and let's move forward, and we can look at this in a little bit more detail. What's going to happen, let's say, up around here? One of Jim's maps, sea level rise planning maps, this is a bit more recent, and I'll show you some areas around our Brooklyn that otherwise would be inundated, but they're probably going to defend them. Going out to the eastern end of Long Island, there are a number of areas out there. Shore protection likely, other areas which are brown, almost certain. One of the things you can do with propaganda is you can have simulations where these are forest screen captures from a little planning, from a little animation that shows the inundation of Edgartown out on Martha's Vineyard. A glaciologist, Brian Perizek, shows the effects of Florida in the event of a Greenland ice sheet melting. and then the Greenland and West Antarctic ice sheets melting. He has a third one which shows an incursion of the sea into Georgia. Al Gore, An Inconvenient Truth, and I can zip through these fairly rapidly. You can get the impression. Graphic images are used to show the plausible impact, significant amounts of sea level rise. What the bombers didn't do, well, the seas might, although there probably would be seawalls built around the World Trade Center. The final series of slides are concerned with an atlas of climate change. And I'll stop on this map here, where we basically see an area that's going to be inundated by just a 1 meter rise in sea level along the lower Hudson. This is also an area, too, where New Jersey Transit in Hurricane Sandy, there was a warning that there was going to be extensive flooding there. And they had railroad storage yards. They stored trains. They were advised to basically get the trains, passenger cars, locomotives, to higher ground. Actually, you have passenger cars with their own electric motors, and they didn't. And I think the price tag on this is running over $100 million. Stupid. If there's any scandal that should impact the Christie administration, where people are related to it, it's not the backup of cars approaching the George Washington Bridge. It's the fact that they didn't get the trains to high ground. Anyway, thank you very much for your attention.
Thank you. That's fascinating.
Just a few more slides, by the way, on your way out. There's a project out in California called Light Blue Line. And some of the humanists would have an interest in this, because the idea here is to have a so-called installation where you get people actually marking on the landscape where you have the 15-foot, no, 7, let's see, wait a minute.
We're going to have time for questions, but I know some people have class right away. So if you want to hang and ask a question, please do.
Yeah.
Personally, I'd like to know when that next 100-year flood is coming.
Yeah. 7 meters, 23 feet. Actually trying to plot this on the land so that people can actually walk. Hey, it's going to be here. Somebody, yeah, happy to.
Okay, we've got the changing of the guard. But
Okay.
any questions here? If you're leaving, please do so quietly. And drop your name and name tag number off before you leave your students. Donna.
I have two, I think, related questions. One is very simple. You referred to the high seas and the open seas.
The high seas.
Yeah, and
The correct term, I think, it's the high seas.
Okay, so it got me to think about the origins of some of these terms, and also got me to think a little bit about what you said were historic artifacts, which for me are the things that I, in the period I studied. So I wondered if you could talk a little bit about the connection between the evolution of decisions about coastlines and kind of the geopolitical boundaries and the technology that evolves, and how those two work together to kind of figure out what those boundaries in the sea and on the coastlines should be over a period of time. I mean, at some point, some of these things might go back to the 17th century, but a lot of the kind of developments about, this is your territory, these are your seas, the continental shelf line that allows people to claim Antarctica, a certain amount of development of technology has to be key in those decisions.
Okay, let's look at some of the technology involved. In terms of United States coastal cartography, we go back to the relatively early part of the 19th century. And they set up what's called the Survey of the Coast. And this organization had a lot of fits and starts. And there's the issue of funding. There's the issue of who was going to run it, who was going to be in charge. They imported, I guess that's an appropriate term, Ferdinand Hatzler, a Swiss mathematician. And he basically was brought in to set up a strategy for producing accurate coastal maps, accurate in the sense of fit for use. Cartographers, by the way, have oftentimes labored over this notion of what do we mean by accurate. We talk about accurate maps, the degrees of accuracy. I was on a panel that was concerned with cartographic standards one time, and how does one come up with the definition of accuracy? We said the only definition we can have is fitness for use. It's something that has to be related, to how you're going to use these maps. In any event, they were concerned in the early 19th century with two problems. One was the defense of the coastline, because basically, Britain might want to get its hooks back into the U.S. There might be some other nations which might invade, and the principal sort of military boundary at that time. There were some things that we thought we would perhaps maybe take a chunk of Canada. It's a totally different story. But basically, fear of invasion from the sea.
But also fisheries.
Okay.
Fisheries key?
This also comes in terms of fisheries, basically maritime commerce, including maybe fishing vessels, sort of coming back. Now, I know virtually nothing, let's say, about the Great Banks or in terms of fisheries there. I do know that maybe several decades ago, in conjunction with the law of the sea, there was a case before the World Court where there was a contested boundary between the United States and Canada concerned with fishing rights. And a concern, with basically, how you were going to anchor that boundary, and that was resolved basically by judges looking with evidence, looking for something that could be operationally simple and straightforward, and that seemed to be pretty much kind of a compromise. But if we go back to coastal cartography in the early 19th century, it was a matter of trying to get a sense of hazards. Trying to get a sense, let's say, of where the sea bottom was just maybe too close to the surface, where a ship might be caught up on something. Now, bearing in mind, there are some areas, where you do have shifting sands down there, so it's not quite as stable as you might like. But if you can get a sense, where there's a fairly good depth, knowing about this is important. And if you have a sense where the depth, might not be that great, then certainly knowing about that was worthwhile as well. So, concerning the fact that the coastal shipping, had to be safeguarded by having a knowledge of problems that you might encounter in sailing too close to the land. This is one of the primary objectives of this map, but they were also concerned with mapping the onshore area. So basically, Ferdinand Hassler, his most important work had to deal with the actual onshore work, using triangulation, using mathematics, using telescopes, using instruments for measuring angles, setting up stations where you can basically have some sort of vantage point at a certain distance or above the land, where you could then sight at some other point, farther away, and you could sight there, or measure that intervening angle. So, very much concerned with the Enlightenment project of measurement. There's a general notion in cartography that the areas that are most troublesome tend to be mapped first. And the coastline basically was an area that was troublesome from the standpoint of hazards. It was troublesome certainly from the standpoint of national defense. There's also an explanation, why for the longest time the maps of Ireland were much better than those of England. Now, let's see. I guess in terms of coastal fisheries, fishing ports, there certainly is a link between fishing and shipping and whaling And actually meteorology, from the standpoint of basically mariners' logs being used to chart ocean currents, even before the Civil War, yes?
Watching these projections of the future, one thing that I wonder about in terms of the setting of international boundaries and coastal waters and that sort of thing is how responsive, how quickly do states concur about changing baselines with things like international waters?
Okay.
I mean, if the pace of acceleration is going to be going faster, how will states keep up with geographical realities?
Okay, by states, you mean like nation states?
Yeah, nation states,
rather
yeah.
than New York and Pennsylvania.
Sorry,
Generally,
nation states, yeah.
I had that.
States.
Yeah.
I mean, if Florida's disappearing and they're all going to higher ground, what happens to their neighbors?
It's not happening. It's not happening fast enough. I mean, no. Realistically, there is a pretty good notion, that unless we, have we have a rash of, let's say, Mount Pinatubo's, which are spitting up a lot of volcanic ash, which would deflect a lot of incoming solar radiation, that sea level rise is going to occur because basically the oceans are warming, and the oceans warm with a lot of water down there, and just thermal expansion associated with a degree or so of temperature rise can actually give you a significant amount of increase on sea level, and also the melting of glaciers. But in terms of the states, like a small S state, or well, I guess I don't know what small S. I mean,
the change is going to be so small relative to.
Oh, okay. Wait a minute. There's a very important question here because there's some very low-lying nation states. Okay, the Maldives, as an example.
Maldives. I was trying to. Yeah.
When basically there, what are they going to do to defend themselves? At one level, they basically are thinking that the developed world is responsible for only burning fossil fuels, and the developed world, was causing a lot of this problem, and that they should take some responsibility. And the developed world seems to be not inclined to, step forward at this point. What can they do? Well, they can build seawalls. They can put their structures on stilts. They can basically maybe work out arrangements with some other countries to sort of export some of their people, if and when this would happen. It's quite likely that severe storms are going to affect them well before inundation will. And there's a possibility that a severe storm, might basically, conceivably even take out the entire country, which in terms of Western civilization, might, quote unquote, solve the problem. That's very cynical, okay? That might not happen. But, I think the tendency in a lot of things is to basically not do anything until something really bad happens.
Well, we keep having something really bad happen, but we don't do anything
Yeah,
anyway.
well, we have people like Fred Singer with a PhD in, I think it might even be meteorology, a PhD in physics. He has an institute, I believe, at George Washington University, and he's funded by the petroleum industry. And I was on the coastal elevation and sea level rise panel of the EPA, and there's a part of each meeting, where they basically would have members of the general public, if they want to, come and address us. And Fred came in and gave his spiel. And if you're talking about a relatively naive audience, basically people can be taken in by the notion that the evidence isn't really there, okay? But that there are natural phenomena that can explain this, and some people who are the climate change deniers, are really quite clever up to a point. I mean, like so many things, you know, I mean, I can't claim to have analyzed, you know, climate change data. I take my guidance from people whom I trust, who seem to have the credentials. I look at the fact that the IPCC, which that process basically, how do they decide what the projection is going to be? They have people who are admitted to the panel because they have the requisite scientific savvy. People who look at the data. And these people then come up with estimates. And what the IPCC comes up with is not for a given period of time. It's not one number. It's a range of numbers. And but you know, if you look at the lower end of that range, something is really bad going to happen at some point. Another problem is, you know, for most of us, including some of the young people here, you know, when it happens, you're not going to be here. And I think there's a general tendency for people, you know, to be very self-centered and not really to think about future generations. Let them worry about it, you know. I mean, let them worry about the problem with nuclear waste. Do you want me to say something, you know, even more radical? I mean, you know, basically, you know, I mean, you know, when you come down to it, I know a lot of social scientists like to dump on Malthus, and he's been misinterpreted. But by and large, on the average, more or less, all things being equal, it's the human population that's causing this problem. The human population seems to be growing, and basically, you know, if we only had 1 million people in the world, it wouldn't really matter what we did, okay? If we maybe only had 5 million people, it wouldn't really matter. There's a general notion that people will be able to take care of things, such as the food supply. Well, maybe, maybe not. Now, having said that, you know, I mean, certainly I'm not going to, you know, advocate any kind of mass extinction of the human race. But it's the kind of thing, and this is not skeptical, cynical, pessimistic, I guess that's the appropriate term. We probably are going to take care of it because we might do some things with what we're doing with pharmaceuticals. Well, we might precipitate some sort of a pandemic that's going to take out a large part of the population. We might poison our soils. We might poison our air. We will probably figure out some way, inadvertently, to reduce the number of people. And of course, there's all this nuclear war. And basically, when the nuclear club has now been joined by, well, what do you have, India, Pakistan, North Korea, I mean, you know, talk about a loose cannon. It's a dangerous world out there. You know, probably the past, since the end of World War II, has been a relatively peaceful time, you know, except for certain areas, you know. I mean, the Vietnamese obviously would not agree. But you know, I don't know that historians are that much into forecasting. The idea, you know, is that basically you have to look at history, and what does history tell us? Well, history tells us that in the interest of military security, we're quite willing to experiment with devices like the atomic bomb. We're quite likely to pacify autocrats like Adolf Hitler. You know, so I mean, you know, is the world any more civilized now than it was 40, 50 years ago? In some ways, yes. You know, we have PBS, okay? You know, but basically, you know, there are a lot of really scary things out there.
On that very cheery note,
yeah, well, I mean,
I have to invite you all for coffee and cookies, but
right.
please do join us because
Okay.
we're holding the line